Hey, what's up guys, my name is the Cherno, welcome back to my game engine series. So, last time we started upon the adventure of creating a game of sorts in Hazel, and I, to be honest, still don't know what on earth we're making. So if you have any suggestions, just leave them in the comments below and we'll talk more about that later. Basically what we did last time was we jammed in a particle system, check out that video if you haven't already. So now we have this kind of, in fact, let's take a look at what we've got. We have this little demo here with a particle system. I'm running it in debug mode, so it's running a little bit slow. And in fact, while we're at it, maybe let's turn down the particles. So instead of like emitting 50, let's like emit 5 every tick. Okay, that's a little bit better, doesn't run quite as badly. My idea for this game so far is extremely vague. We were gonna make kind of like a top-down RPG style, like Stardew Valley, Pokemon-esque, Zelda, that kind of game. Something that at least looks like that, because our goal here with Hazel is not exactly to try and make a game per se, although I am kind of open to that and I think that'll be a good test. But we want to more or less test the renderer. So we've got a 2D renderer. I would like to render what is more or less a realistic scene for a 2D game, because that's what we're working towards. This year I said for the game engine series version of Hazel, so for the game engine series, effectively, we're focusing on 2D, so we want to create some kind of, like our 2D renderer is pretty much, it's there. I mean, there's obviously some other things we could do and we will do, but so far it's capable of rendering like textured quads, sprites. That's what 2D games are made out of. And that's where this whole like designing a test comes from. So we want a more or less realistic rendering test for a 2D game. Now, there is of course the interaction side of everything. And that's more to do with like not necessarily displaying everything, not necessarily rendering, but the other half, which is like all of your logic, entity component system, and we're gonna get there eventually. And Lua, integrating scripting languages and doing all of that without any C++. Our goal basically for this year, for sure, inside this current version of Hazel, the 2D version of Hazel, is I want to be able to make pretty much any 2D game in Hazel without touching C++ or Visual Studio. That's kind of the idea. And the or Visual Studio part is going to make things a little bit harder, but I've gone ahead and said that, so let's kind of aim for that. But anyway, long story short, for now, we need to build something, and that's what we're working towards now. Now, I kind of envisioned some kind of 2D top-down Zelda-style game, and that's what we're going with. So, the next logical step is to try and actually build a level. We'll build the player and maybe the animated sprites and all of that stuff later, but for now, I want to have some sort of level. So the first step is getting some assets. We need to have assets to actually render. We can draw textured quads just fine right now, and we can bash them all together, and we can do all of this stuff, but we need some assets. So let's go and find some assets. Now, of course, I could make some assets, but this is not really an art series, so we're going to just consult Kenny here, who has just a bunch of free game assets with no strings attached. So if we go into assets, we can hopefully find something here that we can use. So I'll just look through this and maybe I'll find something. There's a whole bunch of 3D models here. That's another really cool thing to note. So when we actually do get around to Hazel 3D, I think we will also be consulting this. And if you guys want more of like an art series on how to make assets, I mean, I am more of a 3D artist than a 2D artist, but if you want that, let me know and I'll come up with something. Okay, so voxel pack could be pretty good, even though that's probably primarily for 3D stuff, but it doesn't matter. I think they're textures. I kind of like this map pack, but it's got a whole lot of stuff that we don't really need. Let's see if we can find anything better. RPG base, that looks pretty much perfect. Let's take a look at that. Okay, beautiful. So it's got some buildings, trees. Okay, let's grab this one. Okay, and now that we've got this, let's take a look. So we've got them all as separate PNGs, which is nice, but you can see there are a whole bunch of them. Wow, this is a big pack, 229, that's quite a lot. And then we have them all as a sprite sheet. So if we open this up, yeah, perfect. Okay, so this is what we want. And this is actually what we're gonna talk about today. Let's take a look at the sample. Yeah, that's beautiful. Okay, so this is exactly what we're going for. This is the aesthetic. I think this should be our next step. Now I mentioned sprite sheets, and that's kind of what we have in these packs. A lot of these tile-based, fairly low resolution-ish like art sets or games really will function on sprite sheets or texture atlases, meaning what they do is they basically jam a whole bunch of textures into one image or one texture. And that has a lot of benefits. For one, you might recall that our batch renderer has a limit of 32 texture units or texture slots. That's pretty much if we look at modern GPUs, that's round about how many textures you can bind at any one time for one draw call. You can't really have more than 32 textures bound. I say you can't really have because technically you can, but we're not going to talk about that. In the traditional sense, 32 textures is our limit. You can see that we had like 220 or 229, I think, different textures or different tiles within this kind of pack. If we had a scenario where we wanted to render all of them at once, we could definitely do it, but it means that we have to split up our scene into many, many draw calls. So if we had like 128 different textures and we were somehow using all of them per draw, that would already be like 4 draw calls. So I want to kind of emphasize though that that's not necessarily a problem. It's not like a huge deal for us to have 4 draw calls. 1,000 draw calls is probably getting up there. 100 draw calls is totally fine. So don't stress too much about draw calls. That's not my intention with what I'm saying. What I am saying though is it's very impractical to have 200 different textures. If we have 200 different texture assets in Hazel for every kind of tile, it's not good because we have to constantly be binding, rebinding textures, sorting them into draw calls. It's just very difficult. And they're so small, these textures, that batching them together into one texture just ends up being a lot more efficient. Not just for your GPU, but for you. It's just easier to deal with. So that's why today we're going to be introducing sprite sheets. Now, I don't imagine we're going to just get them into Hazel and come up with a proper API all today. This is more of like an introduction. We'll probably continue this on next episode, but essentially what we're going to do today is we're going to try and render something on the screen using these kind of sprite sheets that we have from this asset pack. So coming back here, what we have, let's take a look at this sprite sheet one more time. So there's two, there's this kind of normal one and there's a 2x one. I'm assuming it's just high resolution. Let's grab this one. So we have RPG pack sheet 2 times. Let's copy that. I'm going to navigate to sandbox assets and then textures. We should probably start splitting this off into a different game as well, maybe. If I go back, maybe we'll just make a new folder called game, and this is kind of the test game that we're talking about here. So we'll do assets, game, and then within here, we'll have our folder called textures, and we'll put that in here just to make it a little bit more organized. And we might do the same with the code as well, because I don't really want this game to be part of like sandbox, maybe, because that should just be like a quick test. If this game ends up being quite large, I don't want it to be this huge burden for people. So we essentially might just separate it out, but we'll see. For now, we'll keep it in here. So we have this sprite sheet. Let's drop it into Photoshop so that we can take a closer look. All right, what do we have here? Okay, so this is, let me just make this window the correct size for you guys. All right, so this is the asset pack. The reason I opened it in Photoshop is very simple. We're not going to be editing it or anything like that. It's just so that I can like measure things basically. So if we take a look at one of these tiles, I mean, what's a good example? Maybe like this one here. You can see that it's I'm assuming it's a power of 2. It's around about 128 pixels by 128 pixels. That is the size of these sprites. Now to use this as a sprite sheet, meaning to render a quad using just a portion of this texture, is fairly straightforward. All we need to do is set different texture coordinates for our quad. Instead of setting the typical kind of 0 to 1, for both X and Y, which would mean the full texture, which is what we've been doing thus far. What we want to do instead is work out what texture coordinates a subregion of this texture would have. So in other words, if we know that the texture that we want to render, like this thing, for example, starts at 512 X, and then maybe like 770 something Y, we need to just simply convert that to a range that's between 0 and 1, 0 being the beginning of the texture, 1 being the end of the texture in both the horizontal and vertical axes, and we basically have our little subregion. So in other words, texture coordinates are always going to be between 0 and 1. It's kind of like normalizing the width and height of this entire texture from pixels into this kind of 0 to 1 texture coordinate space. We need to do that, and that will allow us to just kind of select a texture or a subregion of this image to render. Now, it is going to be a lot simpler when I actually show you guys how, but the important thing for us to know to actually make this whole system work is how big is each texture inside this sprite sheet. In this case, it's all really easy for us because they are all pretty much the same size. I mean, we do have things like trees, which are double height compared to their width, but that's also fine. Most of this is pretty simple. We don't really have a huge complex, like every sprite is different size. They're all just powers of 2. All of them are 128 by 128 with some exceptions. everything is going to be super simple. So we need the size of each tile or each texture within the sprite sheet, as I mentioned, and also the total size. So we know that the width is 2560 and the height here is 1664. All right, that's important information because what we're going to do is we're going to divide the width by the size of each texture, and that's going to give us basically an index. And so if we know that a given texture, for example, these stairs here, start at a particular pixel offset, we can just take that pixel offset, so here it's like 894, and divide it by the total width. That's going to give us a value of maybe around 0.3 to 0.4 for something like this. It's going to give us a value between 0 and 1, which is going to be our texture coordinate. And then we just need to kind of track down all 4 corner pins and set them to the appropriate texture coordinate for the appropriate vertex. That is it. It's quite simple. So diving into Hazel, let's first of all load this. So what I'll do is I'll come over here, and this is going to be, again, this is more of an introductory episode, so I will just basically duplicate the texture that we had here. I'll call this M Sprite Sheet, and I think I deleted the other one. Yep, I did. M Sprite Sheet. Then we're going to load this sprite sheet. So this will be equals, and then I will take this, assets, game, textures, and then let's grab the name of this. So RPG pack sheet 2x.png. Let's pop that in here. Now we should have the sprite sheet loaded. And if we want to render it, let's just render it as a test. I will maybe render it. Okay, we have all of this. This is like our test scene. Let's start a new scene. Let's make it right before the particle system. I'm going to do a begin scene and an end scene. And then if we come up here to draw quad, maybe the checkerboard texture one, let's just try it and draw a quad here. We'll just draw it at 0, 0 maybe. I'm going to disable all of this other stuff, so that should help. And then we'll just give it a size of 1 by 1, which of course is not the aspect ratio of the texture, but that's okay. Sprite sheet, and then we can take away the tiling factor there. Okay, cool. And let's maybe, so this stuff, I do ultimately want to keep this stuff because it is kind of like our test. I just don't want it to render at this given moment. So I'm just going to disable it by just writing an if 0 and if. All right, so now that stuff's disabled. What we will do probably next time is move all of this game stuff into like an actual game example. So I might even make a new project called like game example, and it might even be external to the Hazel repository because Sandbox should be internal to this just for like internal testing and stuff like that. But the game probably shouldn't be. So we'll talk about that next time, I think. All right, anyway, so draw quad sprite sheet, and we've still got the particle system and it's rendering here. Okay, let's hit F5 and see what happens. All right, beautiful. So we have this and we've still got that particle system. We can zoom in and look at this and it looks pretty good. I mean, obviously the aspect ratio is wrong because we're rendering it on a square, even though the texture is wider than it is tall, but that's okay. We have the texture in the game engine. Now we can talk about the actual texture coordinates. So let's try and draw one of these. So let's pick maybe this orange bush. Orange because that's how I roll and it's a nice kind of bush and it's kind of in the middle of the sprite sheet. So this should kind of prove our point. So we need to figure out basically the X and Y coordinate of this in terms of actual tiles. So this is clearly the first one. That's the second one. That's the third one. So it's the third on the X axis, meaning if we start at 0, it has the index 2. The real point of this is to identify the pixel offset of this. So if everything here is 128 by 128, the fact that it has the index 2 here means that it's going to be 2 times 128, 256. That is the offset. And you can see that if we look at this and measure this, that is in fact the starting X offset here. That's the important part. Now, of course, we start from the bottom. So 0, 1, 2, 3. So it's 2 on the X and 3 on the Y. That is the index of this. That's all we need to know. So if we go back to Hazel, let's take a look at the exact function that we're using to render this. So I think this is going to be, if I just hit F12, yeah, it's the one with texture, tiling factor, and it's the not rotated quad. So these are the texture coordinates that we have. Someone, I think via a pull request, basically rewrote this into like a for loop and all that stuff, which is fine. We're going to change these texture coordinates. That's basically what we're going to do. So let's take a look at an example. So we want basically the X index here to be 2. I think that's what we said. And then Y is 3, right? Let me just double check that. 0, 1, 2, 3. Okay, good. Yeah. So taking this, we also need the width and height of the texture. So I'll do sheet width at 2560. And then I think the sheet height was like 1660, something like that. Let's take a look quickly. Measure this. What are we at? Oh, that's the width. Okay. Height. 1664. All right, cool. 1664. So we need that. And then also we need the size of each sprite. So I'll say sprite width 128 and then sprite height 128. And then these are all floats. Let's just make sure that we write them as floats. Doesn't matter too much. Also, just to be clear, in fact, it's not already clear. This is obviously temporary code just to prove a point and just to show you guys how to render this. We're never going to keep this inside a draw quad function. This is absolutely external stuff. And in the coming episodes, we'll be kind of abstracting, I guess, all of this into some kind of texture atlas API that we'll be able to easily use to provide a single texture and then render with some kind of subregion of that texture. Once we have that, we need to figure out our texture coordinates. Now, again, this is going to be fairly easy, but let's kind of talk about it in depth. So our 4 texture coordinates at the moment are 0, 0, which is the bottom left, 1, 0, which is the bottom right, 1, 1, which is the top right, and then 0, 1, which is the top left. Now, what's going to happen is the bottom left coordinate here is now going to become whatever x is times the width of the actual sprites. So in other words, this will take this to be 256, which is the pixel offset of the bottom left corner, or specifically in this case, the left edge, because we're just dealing with the x-axis, the left edge of that given sprite. So in other words, if we zoom into this orange bush of ours, then this edge is exactly what we're calculating right now, because that's going to be this texture coordinate. In fact, if I can draw something here, maybe everything will be better. So that's a terrible color. Let's make it like red or something. So this is the kind of coordinate that we're calculating right now. This is going to be a value between 0 and 1, and we're calculating that value based on the pixel offset divided by the entire width of the image. Then we're going to do the right one here, then we're going to do the top right one, and then we're going to do the top left one. And that's going to give us our 4 texture coordinates, and it's going to allow us to render this. So let's go back to the code. X times sprite width, and then divided by sheet width. Okay, so now this is going to give us a value between 0 and 1. Now let's paste this into here, except this is going to be y times sprite height divided by sheet height. Now the sprites are all square, so we don't really need sprite width and sprite height, but I'm just keeping this a little bit more flexible. All right, now let's copy and paste this a whole bunch of times and change everything. So the next one, as I said, was the bottom right, meaning we now need to advance x, or the x coordinate, by 1, or you could also just add sprite width again at the end of this. But what I'm going to do is just say x plus 1 here. So x plus 1 is going to apply to both of these because these are the kind of the 2 right edges. And then these bottom 2 are the 2 top edges. So this will be y plus 1. And this will also be y plus 1. Okay, that's looking good. Now, we also need to const x per these. And I think that's pretty much it. So now we should have our correct texture coordinates, unless I've just made some kind of silly mistake here. So obviously the part here that's variable is, well, all of these. I mean, what texture within that sprite sheet are you rendering? That's what this selects. The sprite sheet width and height is also dependent on the actual texture. This will be the texture width and height. And in fact, I think we could make this a little bit better, this code, by just using texture get width and get height instead of, you know, hard coding it here. But since everything is a const expression for now, I'll just leave it as is. And then of course, sprite width and height is something that you would need to define when you actually create that texture atlas using our API. So that's pretty much what will happen in the future. Anyway, now what should happen is every single quad that's rendered with this draw quad function is going to use some kind of crazy UV value, some kind of crazy texture coordinates that will, in our case, when using this texture, map to just this orange bush. So let's render this and see if we get the orange bush. And you can see that we do. There is the orange bush, and it's got the particles in front of it. Let's maybe try and draw the particles behind. I think the only real thing that we need to do that is we should probably change the order here. And then I'll also push this like a little bit forward. All right, so now we have this in front. So we've basically tested to make sure the alpha's coming through correctly. We even have a bit of a shadow here. Guess that's kind of hard to see in here. I didn't even know that it had a shadow. Let me just make a new layer and double check that that's actually there, although I'm sure that it is. Yeah, okay, so we do have this kind of nice shadow here. Cool, all right, so that is in fact the bush. Now it does look a little bit like pixelated, and there's 2 things going on here. First of all, that's just the way it's gonna be because it's 128 by 128, and it's also trying to be kind of smooth. You can, of course, change the filtering to be nearest. So if we go into GL texture and we change this linear here on the magnification filter. Oh, magnification filter is actually set to nearest anyway. So, okay, it's already on nearest. If we set it to linear, then it would try and interpolate the values, I guess, and that would be a little bit different. All right, looks pretty much the same here. And that would probably be because I'm not actually editing the right function. That's classic. Okay, so let's change the magnification to linear on the one that actually loads from a file. This is why we need to combine everything into like one function and really clean this up. But anyway, yeah, so that obviously looks very blurry because it's actually trying to linearly interpolate between the values when magnifying. So let's change that back to nearest. And that's probably something that we'll stick with. Now, obviously we are kind of looking at it really zoomed in. It'd probably be about this big if it was a real size. Let's try a completely different texture here. So maybe these stairs. So let's take a look. So that's what? 0, 1, 2, 3, 4, 5, 6, 7, I think. And then from the bottom, 0, 1, 2, 3, 4, 5, 6. So 7 by 6 is the coordinate for that. Let's go into our renderer. We'll change X to be 7, Y to be 6. Let's launch that. And as you can see, we get our stairs. Now you'll notice that this looks perfectly sharp. That's because these are all just straight lines. There's no kind of, it's not attempting to be smooth. It's just trying to be like a bunch of blocky lines. And that's always going to look good when you magnify it using nearest filtering. This is basically why something like Minecraft will look super sharp. The textures will look super sharp, even though they're 16 by 16. It's just because they're all very blocky and they're just being magnified using nearest filtering. And of course, that's just going to snap to the nearest pixel and everything's going to be fine. Okay, cool. So now we can render a whole bunch of different sprites from within one texture. And that's going to be really beneficial because obviously we have more than 32 textures here. We can still all render them with a single draw call because essentially the texture, so to speak, what determines which of these textures we use is the texture coordinate. That's going to be in the vertex data, which is something that we stream into the vertex buffer. So in other words, we're still only going to be binding a single texture and we can render all of these sprites and more in a single draw call. But the more important takeaway here is not the fact that we have one draw call, it's the fact that we have 0 texture state switches. It's all just one texture. We don't need to rebind other textures. That's really what's going to make rendering from this sprite sheet a lot faster. Anyway, I hope you guys enjoyed this kind of introduction to sprite sheets. Next time, we're going to continue on with this and probably create some sort of API so that we can actually properly do this instead of just putting a bunch of code into the draw quad function of our renderer 2D, because obviously that's very temporary. It's not going to work with like any of our other textures, for example. So we'll do that next time. If you guys have any suggestions for what this game should be, I know that's a pretty hard question, and it's probably, I need to probably just sit down and try and design this thing, but we're still fairly early days with this, like to the point where we're just trying to figure out how to get sprites and how to make a level, and then we'll probably move this out into its own project and do all of this kind of necessary, like boring stuff that we have to do in the beginning when we actually get to more or less creating some kind of scene with all these different elements and stuff like that. That's when it's going to be a lot more important. But if you have any ideas, leave a comment below. Also, there's Discord Game Engine series on Discord. I might even make a special channel just for this game if it gains some traction from the testing that we do. But this is good because this is not just going to end up being the candidate for testing our renderer, but it's also eventually, hopefully, going to grow into being the candidate for testing our like interaction and scripting and ECS and all of that fun stuff. Hope you guys enjoyed this video. If you did, please hit that like button. Also, check out patreon.com/thecherno. It's the best place to help support my channel and everything that I'm doing here. If you guys are interested in more 3D stuff, you can check that out. I also did release a devlog the other day that was just showing what I've done in the Hazel dev branch. Check out that video if you haven't already. And yeah, I will see you guys next time where we're going to continue on with this fun little project. Goodbye.